Okay, guys, let's start. Hello and good afternoon. Hope that you enjoyed your weekends. Now we should start with our class. So let me do recording from here also. Start recording, yeah. So now let me share my screen. Sound. Yeah. Can you hear me and can you see the screen?
Hello, sir. Yes, the screen is
Okay,
visible
that's
and you are
perfect.
audible.
Okay, that's perfect. So we just started last class about intro to probability and the foundation of this one. So we just covered some of the questions. So in here it is probability provides a systematic way to measure the likelihood of events or model uncertainty in real world situation. So it helps us create predict outputs, access risk, and make better decision in the field of finance, medicine, engineering, and everyday life. So we covered these ones and we said that there are some key probability terms: experiment, output, simple space, event, and simple versus compound events. Then we covered these all in details and then we watched a video and there was basic probability rules. So we have non-negativity. It means that it should be always greater than equal to zero, and it's between 0 and 1. So our probability cannot be negative. Normalization, it is equal to 1. So the all the sample space, if you calculate all of this one, if you calculate the event and it's a complement, it's always 1. It should be 1. And additivity and for disjoint. So we all covered these ones in detail. Then we looked towards this union, intersection, complement, mutual exclusive events, and exhaustiveness events. For till here, do you have any question, guys?
No, sir, no question.
Okay,
No.
that's perfect. So we will cover today as a counting principle, and it's something that we should see how it works. So counting principles, we have some multiplication rule, multiply outcomes of each event to get total outputs. If event A has m outputs and event B has n outputs, then we have total is equal to m times n. For example, you can say that how many times or how many ways you can wear three shirts and two like pants. So if you have three shirts, the m is equal to 3 and shirt is equal to 2 or vice versa. So you can say 3 multiplied by 2. So in 6 ways you can have or you can
I
wear.
can't hear.
You cannot hear me?
Yeah, now I can hear you.
Ah, that's perfect. Okay. So I said multiplication rule is multiplying outcomes of each event to get total outputs. So if event A has m outputs and event B has n outputs, then we have total outputs is equal to m times n. As I said, I gave you example that in how many ways you can have like three shirts and two pants, and in how many ways can you wear this one frequently. So you can have like 3 times 2 at 6 ways. So you whether you have used shirt number 1 with the pant, or shirt number 1 with the pen number 2, or you can say shirt number 2 with pen number 1, shirt number 2 with pen number 2, and the same goes with shirt number 3 with pen 1 and pen 2. So in 6 ways you can have it. Then we have factorial product of all numbers from n down to 1. So you have like 4 factorial. So factorial of 4 is equal to 4 times 3 times 2 times 1 is equal to 24. And we have another very important topic, is permutations and combinations. So permutation is number of ways to arrange items in order. If you are going to, this word is very important, in order. If it is the order matters for you, so you will use permutation. So 5 students arranged in 3 chairs. So if, for example, you are having 5 students and you are going to arrange in 3 chairs. So student 1, 2, 3, in here order matters which one. So if order matters for you, it's n factorial divided by n minus r factorial. So for permutations. And for combinations, unordered number of ways to choose items without order. For example, if there is no order, is not important for you, so you can choose 3 players from 5. For example, you are like choosing three random people or without any order. So you can say that, okay, Ali, Zakir, and Hussein, you can come. So in here, combination you can use. But if you are choosing for like a presidency election or something, so in here you can say permutation matters the most. So we can have here examples, but before example, let me go to a video. We can see how it is in a very short accounting principle. I hope you can hear it.
Let's talk about clothes. Everybody has them, and we put them on every day.
Can you hear it?
Yes.
Okay, that's perfect.
Yes, sir.
To keep it interesting, we always try to wear something different, or else it would just be boring. So how many ways can we wear our clothes? Well, let's figure it out. Let's say, for example, I have 3 pants and let's say 4 shirts. Well, then how many different outfits can I wear? Okay, so if I put on a pair of pants, it means that for every different shirt I wear, I have a different outfit. And every time I change my pants, I can wear each shirt again as a new outfit. Using math notation, we can describe this as 3 times 4, which is 12. Let's say now I have 2 different pairs of shoes to wear, too. For each pair of shoes I put on, I have a whole new outfit. Since I have 2 pairs of shoes, I can say I have twice as many outfits. This can go on for as long as it needs to, depending on how many elements of your outfit there are. By multiplying out all the possibilities like this, we're using something called the counting principle. As a general definition, the counting principle is this. When there are m ways of doing one thing and n ways of doing another, there are m times n ways of doing both. This is true for pants and shirts, cars and brands, hats and colors, and everything else that has some kind of variety. What if I had, for example, 4 shirts, 4 pants, 4 shoes, and so on? Well, by using the counting principle, we know that I'll have 4 times 4 times 4 and so on different outfits to wear. Or if I have a lock, which has different slots, and in each slot I can choose one of 10 numbers. Then that means the total number of possible solutions is 10 times 10 times 10 and so on, depending on the number of slots. If we have 10 different numbers, which is x, but this has a formula with variables. N is the number of things to choose from, and R is how many times you can choose. This is called a permutation, specifically a permutation with repetition. It has repetition because, like in the lock example, we're able to choose the same number more than once. But what if, once we choose a number, we can't do it again? This is like drawing cards out of a deck. Once you draw a card and put it somewhere else, you can't draw it again. This is a permutation without repetition. Thinking about this mathematically, it's very similar to permutations with repetition. When we have repetition, we multiply out the number of choices we can make like this. N times n times n times n. But if we're not able to repeat, then every time we make a new choice, we have one less option because we picked it the previous time. N times n minus 1 times n minus 2 times n minus 3, all the way until we hit 1. Let's say we're making a computer password using the 26 letters of the alphabet, but once we pick a letter, we can't use it again, and we want it to be 4 spaces long. Well, for the first space, we have 26 choices, one for every single letter. For the second space, we have 25 choices, because we already chose one in the first space. In the third space, we have 24 choices, and 23 choices in the fourth space. So I do 26 factorial, right? Not exactly. This is the problem. If we do 26 factorial, it'll multiply every number between 1 and 26. But we only want the first 4 numbers, 26, 25, 24, and 23, since our password is only 4 spaces long. So how do we get rid of the rest of these factors? We divide them out. But what do we divide by? Well, let's see. We have 26 factorial on the top. If we divide every factor we don't want by itself, which is always equal to 1, then we're left with the numbers we do want. Let's see, the 22 cancels out, the 21 cancels out, the 20 cancels out, all the way to the end. As you can see, we've created a factorial on the bottom now, 22 factorial. But where did that come from? Well, if you get the number of different choices, in this case it was 26, minus the number of slots or spaces, which was 4, then you get the number to factorial and divide by, 22. This works for any numbers. So, instead of just 26 factorial, it's 26 factorial over 26 minus 4 factorial. And don't forget the parentheses. This means there are 358,800 different ways to make our password. The formula for this is n factorial over n minus r factorial, where n is the number of things to choose from and r is how many times we can choose, just as we established. Since mathematicians are lazy and don't like to write as much, they made a new kind of notation just for permutations. It looks like this: a normal-sized capital P with two smaller numbers besides it. The one on the left always represents n, and the one on the right always represents r. When you see this, you solve everything just the same. It just tells you the information you need. Okay, so far we've covered the counting principle, permutations with repetition, and permutations without repetition. So let's go over combinations without repetition. Before we start, I have to make something clear. Permutations are different from combinations by this simple rule. Permutations are different with each order of choices, and combinations are the same no matter the order. For example, let's say balls labeled 1, 2, and 3 are chosen in random order. The possibility of picking 3, 2, 1 is a different permutation than 2, 3, 1, but still the same combination. Since each combination includes multiple permutations, we're going to have fewer combinations of balls than permutations of balls. In fact, there's only one combination of balls to pick in this example, but there's 6 permutations. Where did the 6 come from? Well, we started with 3 balls. If you take 3 factorial, you get 6. This works for any example. There's always r, the number of times we choose, or slots, factorial, more ways to make permutations than combinations. So if we divide the number of ways to make a permutation of something by r factorial, then we get the number of ways to make combinations of it. And that's our formula for combinations without repetition. Just divide by r factorial. As for notation, it's the same as before, only with a capital C instead of a P. And that's really all there is to it. See you later.
Okay. Do you have any question? Was it clear, guys? Am I audible?
Yes, teacher.
Okay,
Sir,
so
it
that's
was clear.
perfect. Okay, so now we have an example. A code has 22 letters followed by 3 digits. Later digits can be repeated. In how many ways can 6 distinct books be arranged on a shelf? And also how many ways? So first of all, if we go with the first question, so code has 2 letters followed by 3 digits. If you see here, so what is it? It's multiplication. So you know in here that we have 2 letters, and letters in English is 26. So we have 26 times 26 and followed by 3 digits. So in digits we have 10 from 0 to 9. If you have 10 multiplied by 10 multiplied by 10. So it's equal to this much. So you can see 26 multiplied by 26 multiply by 10 multiply by 10 multiply by 10. And for the other one, in how many ways can 6 distinct books be arranged on a shelf? So for question number 2, you can have based on this one, it's factorial. So 6 factorial. So you can see here. So in how many 720 ways you can change, you can put 6 books in a shelf, on a shelf. So how many ways to sit 5 students in 3 chairs? Order matters. So in here you can see here order matters. It means it's permutation. So you can have the formula for permutation 5 factorial because you have 5 students and you have 3 chairs. So in here 3 chairs. So 5 factorial divided by 5 minus 3 factorial, which is equal to 60. And for the other one, choose 3 players from 10 for a drill. Order does not matter. So in here, what is it? Is it combination? So you can see here. So it's 10 factorials divided by 10. So in here you can see it's 10 minus 3, which is 7 factorial, and times 3 factorial, it is 120. So in here it's combination, and you can see here the how to write. See, yes, Zohra.
Yes, sir. Can you please put some light on first question again?
So the first one is a code has 2 letters It's 2 letters followed by 3 digits. So there you can see in English how many alphabets do we have?
26.
26. So if we have 2 letters, it means we have 26 times 26 and followed by 3 digits. And you know from 0 to 9, if you count, it's 10, 10. So if you have like 10 times 10 times 10, it can and it can be repeated. So it means that if you are choosing A, so you next time you can put A again. So it means that 26 will be remaining the same. It's with repetition. Zahra, do you have now question? Zohra, was it?
Clear, teacher. Thank you.
Okay. So we have fifth question, how many distinct arrangements of L, E, V, E, L? So in here, how we can do it? So you can see here, we have L is 2 times, E is 2 times, and V is 1. So in here, we can say 5 factorial divided by factorials divided by 2 factorials. And for the next one, you can see, you can go and probability that a 5 card hand has exactly 2s. So you can see here, so it's just 2 from 3 and 3 from 2 remaining is 48. So for you now, there is a questions. Now you should try to do these ones. Are you going to do it in a group or in here together? Are you sleeping, guys?
No, teacher.
Hello, teacher. We are awake.
Are you awake? Okay.
Yes,
Are you going
teacher.
to do it or I should do it?
I'm sorry, I don't have your voice clear. Is it my problem, network problem, or yours?
I don't know. Others, any idea whose problem is it? Is it mine or a problem?
No, sir,
No,
it's
it's
clear for
your
us.
problem, I think, because your
It's
voice
your
is clear for
it's your problem. Okay, so now let's do this one in a code. So I want to do it in Python. So for this using permutation, we have a very good model. If you go here, if you say math factorial, or you can see here. So if you go down here, you can find math factorial. So if you see here, if you go down in here, so this is for if you want to use factorial in Python. So you say math.factorial. You just call this method on this one. So it returns the factorial of a number. So it's a very good. And if you go down here, math methods, you can see here also a lot of ones. Math.a cosine. So you can say if you want to have arc cosine of numbers, so you can have this one, arc hyper cosine, hyperbolic cosine. All of these you can find all the mathematics here. So I need this factorial here, and also the other one is here. Combination, permutation is also there. So it returns the number of ways to choose k items from n items with order and without repetitions. Without repetition, so in here you can see here, and then I have also combination. So I have all of this here. Let me find where is combination. It should be, yeah, combination is here, met.com. So returns the number of ways to choose k items from n items without repetition and order. So now let's do these questions together in Python. So how we can do it? Okay, let me open a Google Colab. Google Colab. If you have some questions, you can ask meanwhile. Let me open a new one. Okay, let me copy the first question. Oh, look at this. Now if I copy, it should give you this much. So for this much, there is all code. Okay. So for the first one, a password has 2 letters followed by 3 digits. How many ways can be formed if repetition is allowed? So just we have the same. So for we have 2 letters, which means it is we have
26,
letter
26.
26. Yes, you are right. Letters we have 26. It means we have 26 of this one. And for digits, you just give a variable name. For digits, it is equal to 10. Yeah. So if I say now For password, if I say is equal to, so I will say that I have letters multiply by how many? Oh, you can see here now 2. If I without this one, so it is giving you raised to the power 2 because we have 2 of this one, or you can say 26, which is 26 square. Then times we have letters, digits. It's raised to the power 3, and if I keep it into bracket, so it's the same. Do you have any question so far from here, guys?
Sir, it's digits. You forgot to put S.
Yes, but now otherwise it would give you error if I would. So I will just say that print. If I need to print, so I will print password. So you can see here, it's very easy while coding because you have this very good here library for to solve these questions. So you can in how much is it? Unit 10, 100, 1000, 10,000, like so it's 6 6 lakh or 6 lakhs 26
Right.
76,000. Yeah, so you can save this one 6 lakhs 23,000 ways. You can have like if you have 2 letters followed by 3 digits, so you can have digits. But if it is like repetition is allowed, if it is not allowed, so you'll just because in the first one you can choose 26, for the next one you will choose 25. So you can have like 26 because if without repetition, if you cannot repeat, so you can say 6 multiplied by 26, and for the letters you have 3 digits, so you can choose from the first, then you can choose 9, and then you can choose 8. Yes, Hasina.
Teacher, in here, why you choose two stars between letters and digits?
See here, it's exponential because if you say like 26, if you say 26 times 26, what does it mean? It means the same as 26.
But teacher, letters we have a number.
It means power.
It's power,
26
it's
to the
power.
power of 2.
It's power. 26 raised to the 2.
Power of 2.
So it's like the same. So if you write 26 times 26, it is also the same as 26 power to 2. And here also is
No,
20
teacher,
times.
I mean letters equal 26. Letters we don't have use A, B, C.
We have used ABC, so but we want to find the this one, that in how many ways can I create this one. So I have 26 letters, yeah. Atfar,
Let me tell her. We counted the letters. It's 26. Letters is equal to 26, and then we returned just the name of the letters.
Atfar, just a second. Atfar, are you confused?
A little teacher.
عاطفة ما میخوایم که چیشی پاسورد بفهمیم که مثلا ما با چند طریقه میتونیم که 2 حرف اگه داشته باشیم و 3 عدد داشته باشیم، با چند طریقه میتونیم که او را یک پاسورد تشکیل بدیم. درست یا نه؟ ما ببین مثلا 2 لتر به معنی 2 حرف، تا حروف انگلیسی چند تا است؟ 26 تا حروف است. ما میخوایم که بفهمیم که چند تا است. مثلا 26 ضرب 26 امکان داره که A باشه، B باشه، C باشه، هر کدامش میتونه باشه. درست؟
Got it, teacher.
Now اگر دیجیت عدد کسا هیرا از 0 تا 9 اگر تو حساب کنی 10 تا نه 10 سو 10 ضرب 10 ضرب 10 اگر او را مثلا اگر تو 10 ضرب 10 ضرب 10 کنید همون فرقی با پاچی فقط چیه؟ طاقت همونیه. مثلا توان همون کارمونه که مثلا 10 به توان 3 به معنی 10 ضرب 10 ضرب 10. درست؟ Did you
Got
get
it,
it?
teacher. Thank you.
Okay, that's perfect. No problem. It's perfect. So if you have question, you can ask, no problem, because sometimes we can be confused. So in how many ways can students be arranged in line? So if I go here, if see here, if I paste it here, what does it say? In how many ways can 5 students be arranged in a line? What is it? Can anyone guess? What is it?
I think it's 5 factorial.
Yes,
It
good.
is.
5 factorial.
Yeah.
Yeah, so if I said like arrangement or student, I can say student because it said that in how many ways we can have in a line. So it's not that choosing or something. Just we are going to arrange this one. So we will say so you
So the
can
output should be 240.
yeah. So for this one I will use math. Okay, just for first of all I should import math. You will import math, right? Just like this, import math, and then you will say that student is equal to now I can say math because I import this one. It's just like import math. It means that I just import my import C and I can use now here all the functions that I have with. So I choose what factorial. So I will say choose factorial what 5, which is what if I print the value, print student. So you can see 120. So you are correct. 120 is correct. So we have here. So for now you can use Python like for very easy. Like you can do it. If you have like, for example, not like 5. If you have like, what about 15? Who can say 15 for what's 15 factorial? Can anyone guess? So you can just say math.factorial of 15 and then you can get it's this much. Like I cannot count even. So this is the factorial for 15. So that's why it's very good if you use math.factorial. So and then we have another one. It's here.
Sir,
Yes,
why
please.
do we write math import for having them all maths functions and formulas for data?
Because if you want to get this one, so in here if you see Python math module, it is Python has a built-in module which is already created, so you can use for mathematical tasks. Math modules has a set of methods and constants. So these are the methods. So you can see here, you can use if you math dot like ceiling, it gives you rounds a number up to the nearest integer. So combination, arctangent, hyperbolic, like arctangent, like you can see all of this one. Cosine, you can say degrees, distinct, you can see all of them, and you can see that definition here. So for to get this one, because I need factorial, factorial was here f. So see math.factorial. So returns the factorial of a number. Now for this second question, if I go here, let's see. This here it's written that a teacher wants to assign 3 different roles: leader, notebook taker, and presentation to 7 students. What is it? Which method is it? Is it permutation, combination, factorial? What is it?
I think it's permutation, sir.
Yeah, permutation, you are right.
Combination.
No, permutation because order matters here. So you can have leader, note taker, and presenter. So in here, order matters for you. So you cannot, that's why we use permutation. So it's just easy. So you can see here, so you can have here permutation, it's P. So you can find here permutation. C returns the number of ways to choose K from N items with order and without repetition. So I will just write this one. So I will say that in here, I will say so the good thing is that once you import this one, so it will work for here also. So I will say student role is equal to math dot what is it? It's permutation. So I can find here or I can write. So perm. So perm is for permutation. You can see student math dot permutation and how many ways? So you have like 7 students. So I will say 7 and how many I need? 3. So I will say 7 choose 3. And I'll say now I'll say I can write here print student role. So in 210 ways I can choose, like I can have like leader, note taker, and here as a order matters for me. But if I do it for without any role, without this role, with I can say combination. And the last, okay, second last is that so we have from a group of 12 students, how many ways a 4-member team be selected? So in here, it does not matter for me. I can choose anyone, A, B, C, D, whatsoever. So it's all about what, Mariam?
Combination.
Yeah, it's combination. So I can use this method here, combination from here. So if I go here, you can say math.com. So I'll just say the same. I can only copy paste so that you don't should see. Now instead of perm, I will say com, and I will choose from 7, no, from 12. So now I have 12 and I have 4. So I will choose 4 members from 12. So if I choose that one, it is 495. And the last one is which one is okay. What is this one? Can anyone guess? So in how many 5 cards hands can be dealt for a standard 52 deck? So you have to take out 5 cards from 2 cards.
I think this is permutation. It was permutation or repetition. I think we should use from that.
Repetition,
So
I
is
think.
order matters here or not?
How many 5 cards?
Is it order matters? आया तरतीब मुहिम है या ना?
No, I think no.
No, because here it is not said that you should count A's or
Yeah,
card or
combination.
something. So it's also again combination. So I will just copy paste, or you can say card is equal to like
How we
math.
know, teacher, combination, repetition of these things?
What did you say?
How can we know about this kind of combination, repetition, and other things?
You can know this one that if order matters अगर तरतीब बराश मुहिम بود permutation है अगर तरतीब मुहिम نبود چیه combination مثلا ببین شما بخواید یک نفر انتخاب کنید این وقتی انتخاب داشته چیه permutation درست نه یکی ترتیب داریم یکی ترکیب داریم در فارسی نه
Okay, teacher.
ها
Okay.
Okay then. So it's like we اگر شما مثلا براش ترتیب order matters, so you will use permutation. If order does not matter, you will use combination. So this is the basic trick you can see. Because you can see here in here it's written 3 different roles like leader, note taker, and presenter. It means that order matters. If in here leader is like Zohra or anyone, and note taker, it should not be Zohra because order matters. So for in here, what will be? Mariam can be one of presenter, Atifa can be. So in here, you can have to choose based on order. But in here, if you have like 12 students, I have like 12 students, so I can choose randomly like Atifa, Shukriya, Sakina, and Mariam. I don't say who is it. I just choose 4 members from mine. So without anything. So I'll say come here. So 4 members without anything. But if I say that president is Mariam or something, so in here it is permutation for me. Okay, I will not mix it a lot because you will be confused.
Thank you.
Yes, Mariam.
Sir, if we don't write at the first import math, so we want access to all the functions, for example, factorial, combination, or permutation. We won't access them?
Yeah.
Okay.
Because let me see. Let me give you. Let me go here. Let's just unrun all of this one. I will change the runtime. Let me change runtime. Just a second. I will come to you, Zohra. Give me a second, please. I think now it's unrun. If I run here, see, math is not defined. Name math is not defined because I have to import math. And for here also it's written that math is a module. So if you need something, so you have to do import. Import is very important in everywhere. Like you have to do import in Python so that it should use the module from the backend. Yeah, Sohra?
Yes, sir. My question was about that. What about the random selection? Because we had a question in our assignment 3. It was about selecting randomly the balls. I was asking that which of these function we should use for that question.
You have been to assignment, but in here there are a lot of there is random variables here also. So you should just let's see what will be, and I will see the question. Okay. We have studied some of them, but the assignment is from all the probability, not from only from this one.
Okay, got it, sir.
Yeah. So this is to your question, Mariam. So because if you don't do it, you even for anything you will have to do import because there are some built-in functions modules in Python because you don't need to do like code everything behind this one. So if you want to do it without without this one, so you have to do manually for yourself. Like for example, you will say student role. I will not use math, so I will say that 7 times, I will just use like this. I will say 7 times 6 times 5 times 4. Oh, I have y with shift. 7 times 6 times.
It will be too difficult and time consuming.
Yeah, so that's why. So I just do it. Otherwise, if you don't do it, so you have to do it like the same. You should write the code for the what's this mathematic code because these all are built up on the base of mathematics. So in the back side of this computer, so there is a math working the same, doing the same thing that you are doing. We are not going to supposed to do. But if you are doing it by yourself, so you have to write it as a definition of the permutation. Mobile tarifi permutation या combination या हर चीज़ separation बारे नविष्टा कुनित. Familiar?
Yes. Yes, understood totally. Thank you.
That's perfect. Zohra, again, do you have a question
Sorry,
or
teacher.
Sorry, sir.
yes, Atfa?
Sorry, teacher. In the first question, factorial, you didn't write import the math. It isn't any problem for that?
No, for this one I have just used like mathematics. ما رياضي سادة استفادتهم زربرة.
Got it. Thank
Like this. Let me see you. What is it? Okay. One. I will cut this one. It's just like don't be confused. I will say password. What is it? I'll say ما بستشاش عدد درهم بستشاش ضرب بستشاش ضرب دا ضرب دا ما است any card. جاي عزیزlar قسم çıkardım tavan istifade edelim. بستشاش بتواني دو دا بتواني سين. از خاطر. Atifa confused or no?
No,
Okay,
teacher, no, teacher. Got it.
okay, that's perfect. So we have another topic. It's conditional probability. It's something very unique. So conditional probability is the probability of event A happening when A is happening, given that event B has already happened. So if you are going to count the probability of B, but the probability of B should be already happened. So it's like probability of A. This one you can say given A given B. Probability of A given B. You can read this one like this. Probability of A given B is equal to probability of A and B divided by probability of B. So because B is given already, so you will just divide the intersection of this one. So you need this portion. This one is the same. So it narrows the sample space to only whether B has happened and then looks at the chance of A within that space. Yes, Zahra.
Sir, sorry. When I was doing the assignment, so I couldn't find the sign that you said given.
You didn't
Probably
find? Why you didn't
given
find? You can see
it.
it's sorry,
Yeah.
Zahra. You can find it. You can have shift and upside of these ones. You can see you have entered. Above the entered, there is this sign.
But it's like, yeah, that slash. You mean the slash? But slash is
Backslash. But there is backslash. But if you take shift with that one, it will give you this.
okay.
Yeah, you can find it. It's all okay. So no problem. You should not do the assignment now because you have to do it later. Okay. So how is it like, for example, rolling a dice? So probability of A rolling an even number, probability of B rolling a number greater than 2. So if I find out probability of A given B is probability of rolling an even number given that the roll is greater than 2. So for doing conditional probability, it should be that I have already done this one. It should be greater than 2. So that I should find an even number. So if I have like my sample space for B is 3, 4, 5, 6. And if I say the favorite, because in here it's like even if I have another one. So if I, for example, if I get for simple space for A, if I say for A, so it is like it should be like one number 2, 4, and 5. Now if I find the intersection of this one and of this one, so it is like 2 is in both sets. So 2 and 2, 4 and 4, sorry, 4 here and 6. So I can say 4 and 6. Then I can put it to probability of A given B is 2 because I have 2 of this one. And how many is B? B is 4. So if it is 0.5, so it could be like 4 or 6. So probability of A given B is like this. So for more condition, let's see a short video. I hope it should work because sometimes I don't know why there is problem with. Okay, please guys.
In this video, we're going to talk about something called conditional probability. And the idea with a conditional probability is that we want to figure out the probability of something given that we have some other piece of information, that we can bring to the table that will influence the probability of whatever it is that we're investigating. Now, the way we write this down is with the following notation. We're going to refer to the probability of A given B. So this vertical bar that we have here is referred to as, or read off as, given. And what it means is this is the probability of A, the thing I want, the thing I'm investigating, the probability of some event A, given that I have this other piece of information, given that I know that this event B has occurred. So we want to have some formula for how we're going to compute this. It is a quotient of two things. It is the probability that we have both the event A and the event B. So I write this as an intersection. It means the probability of A and B, all divided out by the probability just of B. Now, the way I like to think about this formula is that we're looking not at all possible events. We're looking at the sort of narrowed sample space of knowing that this event B has occurred. And we're asking, well, what's the probability of A occurring given B? So the sort of sum total of all the possibilities are going to be whatever the possibility is B is going to be, because we know that B has occurred. But then we're asking, well, how often is it likely the case that you have A and B occurring amongst all of the possibilities where B occurs? So that's why we have this formula. This is, what is the probability that A and B occurs? That's the numerator, divided by all the possible ways that B could occur. That's the denominator. Note that in most cases, if we're just talking about non-conditional probabilities, the probability of A is without any other information, we actually are typically dividing by something the same way. It's just that we divide by the probability of all possible events, the entire sample space, the entire universe of possibilities, which is just one. So we are, in fact, always dividing out by something. And in the case of conditional probability, it's that we're dividing out by the probability of B, the thing that we're told has to exist. Now, we can sort of visualize how this is going to work by using a Venn diagram. So a Venn diagram, I'm going to list my entire universe of possibilities. And then I can say that, look, I have, within my entire universe, I can have some probability of an event A occurring. And I could also have a probability of some event B occurring. Well, if I'm looking at this sort of conditional probability, well, conditional probability is saying, look, I'm in the scenario where this event B is occurring. I'm assuming that event B occurs. And then what I'm really interested in is, what is the probability of this event A occurring given that I'm in this event B and that event B has occurred? In which case, I'm really interested in this intersection here. In other words, I care about this ratio of the probability of the intersection to the probability of B occurring, the red divided out by the yellow here. Now in this example, I've given you something. I've given you an intersection. I've told you that the percent of adults who are both male and who are alcoholics is going to be, it looks like 2.25%. I had to look this up. And then the question is, what is the probability that you're an alcoholic if you know that you're a male? We can look at what the probability of being an alcoholic is in general, but I'm interested in this problem is if you know that your patient is a male, what is the probability that they're an alcoholic? So we're going to use conditional probability to figure this out because we know something about the intersection, the probability of being an alcoholic and a male, that's 2.25%. We know what the probability of being a male is, all approximated at 50%. And we can use those two facts together to get the conditional probability, the probability that you're an alcoholic given that you're an adult male. Now, I need to define a little bit of notation before I plug it into my formula. I'm going to let A, this is going to be equal to the particular event of being an alcoholic. And then I'm going to let B be the event that you're going to be a man. So there's two different things we could do. We could ask what's the probability of an alcoholic, what's the probability of being a man, what's the probability of being an alcoholic and a man. That's the thing that we were given. We were given in particular that the probability of being an alcoholic and being a man, that this was equal to 0.0225, or in other words, 2.25%. And so what we're really asking when I ask what is the probability that you're an alcoholic given that you're a man is we're asking what is the probability of being an alcoholic given that you're a man. And we know that from our formula, this is going to be the probability of A intersect B. So the probability of being both all divided by, and then I'm going to be dividing this by the probability of a man, and I'm going to say that that's 0.5. I'm going to assume it's exactly 50%. And therefore,
Okay. Do you have any question for?
Yes,
No.
teacher.
Yes, who was this? Yes.
Teacher here, what he
Sorry.
put instead of probability of B?
Yes, please. Can you come again?
Yeah, sure. I asked that what he put here instead of probability of B in the formula.
So because the
0.1?
yeah, 0.5, he thinks that it's fair. So if male and female, they are equal. So 50-50. So it's 0.5. You can see
Okay,
here.
okay,
Yeah. So in here, what yeah, conditional probability, just a very good example. It was this. That you are a man. Suppose that you are a man, and what's the probability that you are like alcoholic? And the intersection of this one is that 0.0. It's like 2.25%. Like if for girls, if you get for girls, for example, what's the probability? Just a second, let me. Probability of you like girls do shopping. What's the probability? Is it 100%? Suppose that you are a girl and you want to do shopping. So it's the probability of doing shopping given you are a girl. So this is like for you, like you can do it very easily. So like if you have like probability of the intersection is like maybe 80% or something, like doing shopping together, and like then you have females 50%, you can see like you can find out how much is it. Okay. Any question, guys?
Sorry, sorry, teacher.
Mm-hmm.
Can you explain more about the which program has used this person for teaching? When we train or teach online, I don't know this what is this program. They directly write and they show in the TV or their computer.
So you want to have it? So I will give you at the end of the question. The class, okay? It's OBS
Okay,
studio.
teacher, thank you.
It's this studio that I am doing. Can you see my screen? You see my screen, guys? No?
Yes, teacher.
Yes.
Yes.
Yes,
So
teacher.
I'm using this OBS studio. So this is a very good. So you can do many things here. You can record, you can do everything. I will share you the link with you. Okay. Just don't go to this one. Come to conditional probability. Do you have any question, guys?
No question.
OBS, you said, is it
I will
free?
come, Zahra. I will come. Okay, yeah, it's free. I will come to you. Just let's not get confused with this probability. Then I will show you at the end. Okay.
Okay.
Okay. So then we have multiplication rule of probability. The probability of two events A and B both happening is. So if you have like here a probability of A given, so it's just like the intersection. If you multiply this one, if the denominator is 1 here, if you multiply this one with 1 and this one, it will be a multiplication rule for probability. So you have probability of A intersect, or A and B is equal to probability of A given B times probability of B. And if it is like this, but if it is like vice versa, so you can see here probability of B given A, it means that it should be. So you will see the right side of this one always. What is it? Is it A or B? If it is probability of A given B, like B is already happening, so you'll say probability of B. But if in here B given A, it means that B is not happening, A is happening. So you'll say probability of A given B, B given A is probability of A. That's A. In here you can see here that it is A is happening, not B. But in here B is happening, A is not happening. So you should just keep in mind this portion of always the right side, which one is happening. So this rule is useful for sequential events when one event happens after one or depends on another. For example, you have flip a coin, so you have 50%, 50%, and you can do it's all like heads and heads, like you can see here. Do you need a video? Because I'm running out of time. Or should I share it in the group? You will do it at home. Yeah, Zohra?
Yes, sir. For the previous slide, you explained it, how we should know when the event A or B is happening.
It will give you, it will show you. It will give you as example, like this one, like it will give you the probability of, see here, it will give you like this. So for example, in here you have event A, if say B, yeah. So in here it could be changed to it to say probability of rolling. Instead of rolling an even number, given the roll is greater, so you'll say probability of, you will change this sentence. Probability of rolling a dice is like greater than 2, given it is an even number. So it will shift the changes. There will be some changes with the sentence. If you reverse this one, for example, if I say probability of roll is greater than 2, given, now you can see given an even number. Now you can see here that even is happening. So it means that A is happening. So I want to find B because I want to see what is greater than. So you can see here, given. A word given is there always.
Okay, got it, sir. Thank you.
That's perfect. So let me see if we can go and watch. We can watch this one because I'm running out of time. But I want that you should learn. It's also a very big problem.
Stell dir vor, du kannst alles erstellen, einfach indem du daran denkst. Das ist Base44, eine KI-Plattform zum
Now we're going to talk about two basic rules of probability. And the first one is sometimes.
So let me go for multiplication because where is the multiplication? Because you can see watch others also use all here. You can see all of them. Let me see if I can find multiplication. No? Yeah, multiplication. I will share this one. You can please watch all of them because I don't have time, so I will just move on.
The probability of getting A and B.
Okay, let's see here.
The next type of rule is the multiplication rule. So let's say well, first let's talk about conditional probability. The probability of A given B is the probability of getting A and B divided by the probability of getting B. So what this means is that if we multiply both sides by P of B, we can get this equation. The probability of getting A and B is the product of the probability of getting A given B times the probability of event B occurring. Now, what about this scenario? What is the probability of B given A? This is still the probability of A and B occurring, but divided by the probability of A. So if we rearrange this equation by multiplying both sides by P of A, we can see that the probability of A and B can also be written as the probability of B given A times the probability of A. So notice the similarities of these two equations. Now, sometimes the two events that you're dealing with might be independent events. An independent event is an event that does not depend on another event. For independent events, the probability of A given B is equal to the probability of event A occurring, because A does not depend on B. Likewise, the probability of B given A is equal to the probability of event B occurring, because B does not depend on A. So when dealing with independent events, we get this equation. The probability of A and B occurring is simply the probability of A times, not plus, but times the probability of event B occurring, if the events are independent.
Okay, this one also very good point that he mentioned is here, that if the events are independent, if they are not linked with each other, so you can just multiply each other, which was probability of A times probability of B. But for conditional probability, when it is dependent on each other, so then you will use this function. This is very important. Sometimes they are like disjoint, they are not related to each other. Like maybe like two events occurring at the same time, but it's you can say being like doing shopping and men. Maybe men are not doing, so you can see probability of shopping and probability of men, you will just multiply by them. But if they are dependent on each other, then you will use this one function. So these independent events also happen.
If not, then you can get one of these equations.
Yeah.
Depending on what you're given. One thing I do want to mention is that when you see A and B occurring, this means that these two events are occurring at the same time. It doesn't mean A and then B, which could be different from B and then A. So because the events occur at the same time, the order is not relevant. Otherwise, the formulas may be affected. So just keep that in mind. Therefore, the probability of A and B occurring is the same as the probability of B and A occurring, because these two events occur at the same time. So I just want to add that clarification for those of you who may have questions on it.
You can go through examples by yourself. Any question, guys, so far?
No,
No,
sir.
sir, it was
Clear. Who was that one? Your videos are better than you. Who was it? Then?
no.
No, I'm just kidding. Okay. Then we have law of total probability. Now, if B1, B2, and Bn, you have a lot of like events happening. Like there are multiple events and the sample space, like you can see here. Then the probability of event A can be found by you will just take this one. So its probability of A is summation of I is equal to 1 till n probability of A given B I is probability of 1, probability of 2, given B means 1, 2, 3, 4. I is sub index for this one. Times probability of BI. It means if you have maybe it is B1, B2, B3, B7. When different scenarios and tasks make up the entire sample space, we calculate the total probability of adding up this contribution for each group. For example, do I have here example? Yeah. So I have like factory 1 is produce 40% of items with 2% defect rate, and like factory 2, factory 3, I have 3 factories. So it is like B1, B2, B3. So if I see here, so you can find what is the defect rate of multiple, and so I want to find defect rate. So I will just use defect factory by F1, which is like factory 1 factory 2 and factory 3. So all of them are given. So I have like 40%, produce one is 40% of item is 2%. So the defect is 2%. You can see here, it's like 0.02 times 0.4. So in here, produce 40% of items and this produce for 35. So if you will just multiply this one with this and add all of them to find the total defect items. So which is like 3.1%. So you can see factory 1 0.2, 0.02 times 0.4. It's the amount of products that they are producing. Like it's 40% share is with factory 1, and with factory 2 it's like 35%, and with factory 3 it's 25%. And this is the amount of the defection that is happening in factory 3, factory 2, and factory 1. So if you add this one all, it's like in total, the defect in these three factories are 3.1. So you will just use law of total probability. You'll use this one formula. Just in here, you will see the amount of defection and also the share of the factory, that how much it produces. So this is law of total probability. Any question, guys?
No, teacher, is clear.
Yeah. Then we have another function. It's bias theorem. Please keep in mind this is also very important one. I think I have it. Let me see if I can find a video for you also for this one, because it's also a very important topic. Bias theorem, and this one algorithm is in machine learning based on this theorem. So Bayes' theorem gives a way to update the probability of an event based on a new information. So you have like probability of B given A is probability of A times probability of B given A divided by probability of B. Now you have the likelihood of probability of A given B is also happening. New event is also happening here. So B times probability of A is like post previous, like for example update the previous one that happened, and probability of likelihood probability of A if B is true, and in here probability and total probability of A. So you can see an example here. So in here, for example, if you see here that a rare disease affects 1% of the population. So there is 1% population, and a test of a disease has 99% sensitivity. It means that positive given disease is 99%. So whenever the person is tested, so the probability of being positive is 99%, and probability of being negative and no disease, and it is negative and there is no disease is 0.095. Patient takes the test and the result is positive. So now it's a positive, a patient is taken. So what's the probability that the patient actually has the disease given the positive result, test result? So I have like disease probability is like 0.01%, positive given disease is 0.99, and also positive given no disease is 0. Oh, it's typo here. It should be this one. Yeah. Oh, it's fine. It's fine.
Sir, I think it is 1 minus 0.95.
Yeah, it should be. This one is wrong. Let me see. 0.9 times disease and 0. Given. I think there is some problem with this function. Let me see. Okay, let me have a video. I can see it later. Let's see. Or no, let me check it because I'm not sure with this question. Can watch this one.
Imagine you have two bags placed in front of you. Bag A has 3 red balls and 1
Yeah, simple. Okay.
blue ball. Bag B has 1 red ball and 3 blue balls. Now, suppose someone blindfolds you and randomly picks one of the 2 bags. So, each bag has a 1 out of 2 chance, or 50% chance, of being selected. Next, from the selected bag, 1 ball is picked at random and it turns out to be red. You are told this result, that the chosen ball is red, but you still don't know which bag it came from. Now comes the big question. What is the probability that the red ball came from bag A? This is what Bayes' theorem is all about. Let me tell you the main intuition behind Bayes' theorem. See, initially, when there was no outcome, meaning when no ball was selected, we had no prior information about which bag would be picked. So both bag A and bag B were equally likely with a 1 out of 2 chance each. But once we actually saw the outcome, that the ball turned out to be red, we gained new information, and this information makes us update our belief. We might think that instead of still thinking both bags are equally likely, we will now lean more towards bag A, because it is the bag with a higher chance of producing a red ball, right? This updating of probabilities based on fresh evidence is exactly the heart of Bayes' theorem. But now, how to calculate this probability value using maths? This is the well-known Bayes formula you might have seen many times. But I doubt that you hardly know what is going on in this formula and how we even came up with this formula. Let me show you using a simple Venn diagram. Imagine 2 overlapping circles, one for event A, which tells that even A has occurred, and one for event B, which tells that even B has occurred. The overlapping area, or this region, represents the cases where both A and B happen together, and we call it as event A intersection with event B. Suppose you want to find the chance of some event A happening, but you already know that another event B has happened. This means we are focusing only on the B circle, and inside that circle, the overlapping area is the part that also has A. So the probability of A given B is just asking, out of everything in the B circle, how much is also in A? That's exactly what conditional probability means. Therefore, the formula will now be simple. The conditional probability of A given B, which we represent like this, is equal to the probability of both A and B happening together, divided by the probability of just B happening, and that's it. Likewise, the conditional probability of B given A, which we represent like this, is equal to the probability of both A and B happening together, divided by the probability of just event A. Great. Now what can you make out from both of them? We see that the probability of the intersection P of A intersection B can be written in 2 ways. From here, it can be written like this, and from here, it can be written like this. Therefore, we can equate both of them to get this. Finally, divide both sides by P of B to isolate P of A given B. This gives us the proper form of the Bayes theorem. Awesome. Now I will show you one more magic. Coming back to our original problem of finding the probability of choosing bag A given the outcome was a red ball, we can use this formula to find the values. But I will show you a nice tree diagram method which is mostly used when dealing with problems related to Bayes' theorem. Draw a small circle representing the root of the tree, and then 2 branches to the right, like this. At the first branching point, label the top branch, bag A with probability 1/2, and the bottom branch, bag B, with probability 1/2, like this, because initially both of them are equally likely to be chosen. Now, from the bag A branch, draw another 2 small branches like this, one labeled red with probability 3/4, and the other labeled blue with probability 1/4, because bag A has 3 red balls and 1 blue ball. Then from the bag B branch, draw 2 small branches, one labeled red with probability 1/4, and the other labeled blue with probability 3/4, because bag B has 1 red ball and 3 blue balls. Now when we ask, what is the probability that the ball came from bag A, given that it is red? We are restricting ourselves only to those outcomes where the ball is red. That means we throw away the blue outcomes completely, and only look inside the world of red balls. Now, in that red world, there are 2 possible ways the ball could have appeared. Along the path where we have bag A, then red, whose probability will be the product of 1/2 times 3/4, which equals 3/8. And the next is along the path where we have bag B then red, whose probability will be the product of 1/2 times 1/4, which equals 1/8. Together, these two cases make up all the red outcomes, so the total probability of red is 3/8 plus 1/8 equals 4/8. But we want the share of this red world that only belongs to bag A. That is why we take the part from bag A, which is 3/8, and divide it by the whole red part, which is 4/8. This gives 3/4. So
Query, analyze, code, share. JetBrains for Data gives you intelligent.
So at the beginning, before we knew anything about the ball we picked, we had an equal 50% chance of having chosen either bag A or bag B. However, after observing that we picked a red ball, our belief about the source of the ball changed. We updated our probability. And now, based on the new information, we calculated that the probability of the red ball coming from bag A increased to 3 divided by 4, or 75%. Now, if we want to find the same using formula, we apply Bayes' theorem. The probability of bag A given red is equal to the probability of red given bag A multiplied by the probability of bag A and divided by the total probability of red. Substituting the values, probability of red given bag A is 3/4. Probability of bag A is 1/2, and the total probability of red is 3/8 plus 1/8, which is 1/2. So the final result is 3/4 or 75%. Okay, let us level up our gear. We will introduce 3 events.
Okay.
Suppose we have 3 machines.
Events, you can watch it later. Let's see. Do you have any question, guys?
No, it was clear.
No, teacher.
Let me see this one, whether it's correct or no. A rare disease has affects 1%. Okay, of population, a disease has 99%. Positive given is 99. It should be less. Yeah. So we have like a positive is 0.01. It's from here. 1% is fine. Positive given disease is 99. Okay, positive given and positive no disease is 0. Because in here negative and no disease is like 0.95, so it's 0.05. So it's 1 minus this one, so it will be 0.05. Then we have probability of positive is equal to 0.99 multiplied by disease plus 0. Positive no disease is like n times 0.99, and then you can do it, and yeah, it's correct. So it's correct. So the probability of positive is like, first of all, we will counting whether it's positive or no. So we can come here from to this. It should be as disease and also positive. So it will be like probability of disease is 0.01 times probability of positive given a disease is 0.99. So this is here portion, and then we can find another positive is should be positive but no disease, because there might be error with our system or with our device. So we can have like this probability also that there could be maybe test kit is not working or something, but it's showing you positive. So it's positive and no disease is 0.5. So you can say 0.05 times 0.99. So if you add this one, so it will give you the probability of positive. So probability of positive is 0.0594. Now, probability of disease given positive is 0.99 times 0.1 divided by probability of being positive. Yes, Zora.
So in this question, what is the event? Is it positive, being positive or negative, or be thesis or no thesis? Which one?
Disease given positive. So we don't care that if it is negative. We always, when you are doing it in hospital, you care about being a disease and given it's a positive. So it could be, this is our main topic that we are doing it. So it's like probability of disease is here, probability of disease given it is positive.
Okay.
Because there could be in here, it could be positive given no disease. Sometimes, as I said to you, that there might be problem with your device or something, but we are calculating all the possibility of positive, all of them. So that's why we are just keeping all of them. So we will just keep this scenario and also this scenario, because maybe there might be nurse is not fully like had a problem with their testing, or there was testing kit, or there are a lot of plenty of, there could be other factors. There is no disease, but it's showing you positive. And as you know that it will not be 100%, you are not 100% sure about that one. So therefore it could be sometimes positive or no. So we had independence on event. So it's, as I already mentioned, it was also there. So for multiplication, it was two events A and B are independent if the occurrence of one does not affect the probability of the other. So if their two does not have any impact on each other, so you'll just probability of A and section B is equal to probability of A times probability of B. So you don't need to do conditional probability or multiplication rule here. So because they are independent. Independent events can occur together, like probability of this one, like tossing two coins. Like if you toss two coins, it is independent from each other. So it's not dependent with first output of first one. So you'll just multiply, because if you are saying head, so probability of A is 0.5 and for the other is also 0.5. So you just multiply. They don't have any impact, or they are not dependent on each other, the coin. So you can just like use it tossing two coins. And mutually exclusive events cannot occur together. So you cannot have a single coin and you can do two events like head or tail together. But there could be some trick or something, but without that one, getting head or tail on a single toss. If you toss a coin, so you will get either head or tail, but you will not get it together. So that is mutually exclusive, it should be, and also independent. So these two events, if they are, so you can say independence of event. Like here, example is tossing two coins. First one you can see here, like beginning is like you have head and tail 1.2 or 0.5 or 1 divided by 2. Then again you have, so first coin is shows like this one, head and tail, and because the coins are tossed independently, you have done it separately. So it is just, you will calculate 0.5 times 0.5 and it's 0.25. So the probability of coin being like head is this, you can say 0.25 if you has two heads. Do you have any question, guys, so far? All got it?
No.
Is it clear, everything?
Yes.
Yes,
Perfect.
teacher.
Perfect. So what is a random variable? It's also very important topic. Like you can see, we have like a random variable assigns a numerical value to each outcome of a random experiment. So this one is all about, and there are two types of discrete and continuous, like counting outcomes. If there is number of customers, so it is discrete. You can say you cannot half the customer or something, but continuous is measuring outcome of an interval, like temperature, like, or you can say waiting of a line in a for a bus or something like this. So you can see here. So you have like domain isolated values on the number of line. They are not all values are in interval. So because continuous, it should be an interval from 0 to 5 or something. So it will be an interval. Description is like chart of outcomes is like here. You can see here, and probability plot, you can do it histogram. But for this probability density curve you are having, so you will have, because it's an interval, so it will be a curve rather than a portion or a histogram. So you can adding up discrete probability of interest. So you'll have like, if it is less than equal to 8, probability of x less than equal to 8 is like 0.5 plus or 0.2 or whatsoever. But in here you will have as a region, you will have a curve area under the curve. So you will have like some portion of this one. So you can see here, maybe with this one, let's go see one of them. Is it difficult or no?
No.
Okay, that's
What I want to discuss a little bit in this video is the idea of a random variable. And random
variables at first can be a little bit confusing because we will want to think of them as traditional variables that you were first exposed to in an algebra class. And that's not quite what random variables are. Random variables are really ways to map outcomes of random processes to numbers. So if you have a random process, like you're flipping a coin, or you are rolling dice, or you are measuring the rain that might fall tomorrow. So random process. You're really just mapping outcomes of that to numbers. You're quantifying the outcomes. So what's an example of a random variable? Well, let's define one right over here. So I'm going to define random variable capital X, and they tend to be denoted by capital letters. So random variable capital X, I will define it as, it is going to be equal to 1 if my fair die rolls heads, let me write it this way, if heads, and it's going to be equal to 0 if tails. I could have defined this any way I wanted to. This is actually a fairly typical way of defining a random variable, especially for a coin flip. But I could have defined this as 100, and I could have defined this as 703. And this would still be a legitimate random variable. It might not be as pure a way of thinking about it as defining 1 as heads and 0 as tails, but that would have been a random variable. Notice, we have taken this random process, flipping a coin, and we've mapped the outcomes of that random process, and we've quantified them. 1 if heads, 0 if tails. We can define another random variable, capital Y, as equal to, let's say, the sum of rolls of let's say, seven dice. And when we talk about the sum, we're talking about the sum of the 7, let me write this, the sum of the top, the upward face after rolling 7 dice. Once again, we are quantifying an outcome for a random process. The random process is rolling these 7 dice and seeing what sides show up on top. And then we are taking those and we are taking the sum and we are defining a random variable in that way. So the natural question you might ask is, why are we doing this? What's so useful about defining random variables like this? It will become more apparent as we get a little bit deeper in probability, but the simple way of thinking about it is, as soon as you quantify outcomes, you can start to do a little bit more math on the outcomes, and you can start to use a little bit more mathematical notation on the outcome. So for example, if you cared about the probability that the sum of the upward faces after rolling seven dice, if you cared about the probability that that sum is less than or equal to 30, the old way that you would have to have written it is the probability that the sum of, and you would have to write all of what I just wrote here, is less than or equal to 30. You would have had to write that big thing. And if you wanted to write, and then you would try to figure it out somehow if you had some information. But now we can just write the probability that capital Y is less than or equal to 30. It's a little bit cleaner notation. And if we now care, if someone else cares about the probability that the sum of the upward face after rolling 7 dice, if they say, hey, what's the probability that that's even, instead of having to write all of that over, they can say, well, what's the probability that Y is even? Now, the one thing that I do want to emphasize is how these are different than traditional variables. Traditional variables that you see in your algebra class, like x plus 5 is equal to 6, usually denoted by lowercase variables. Y is equal to x plus 7. These variables, you can essentially assign values. You either can solve for them. So in this case, x is an unknown. You can subtract 5 from both sides and solve for x. Say that x is going to be equal to 1. In this case, you could say, well, x is going to vary. We can assign a value to x and see how y varies as a function of x. You can either assign you can assign values to them, or you can solve for them. You could say, hey, x is going to be 1 in this case. That's not going to be the case with a random variable. A random variable can take on many, 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 many different values with different probabilities, and it makes much more sense to talk about the probability of a random variable equaling a value, or the probability that it is less than or greater than something, or the probability that it has some property. And you see that in either of these cases. In the next video, we'll continue this discussion.
Okay. Any guys question?
No, teacher.
Okay. So probability mass function is PMF, so it's for discrete random variable. So if you wanna do it, PMF give us the probability that a discrete random variable takes on a specific value. For example, if you can see here a fair coin once, it could be 0 for tail and 1 for this one. So probability of x is equal to 0 is probability of x given, or probability of x for tails is 0.5 and for 1 is 0.5. You can have like this. So you can say summation of probability of x is equal to whatsoever. For example, 0, 1, 2, there could be many intervals, or even not intervals, many discrete variables. For interval is for probability density function. So you can have in interval from b, like from here to a to b, like this could be an interval for density mass. But if you are using probability dense function for continuous variable, so its direct probability is found by taking the area under the curve. So you have probability of x dx is equal to 1. If you want to find this one, so it's from a to b. So you have lower limit is a and upper is b. So uniform is 0, 1 distribution. So it's just like 0, 1 if x probability of x is 1 for x is less than equal to 0, or greater than equal to 0 and less than equal to 1. So probability of x less than equal to 0.2 and x greater than equal to 0.2 less than equal to 0.5 is 0. So it's randomly. So there is no any such thing. So you can say 0.5 minus 0.2, it's 0.3. So this is the area because it's a uniform. Then you have collective distribution function, CDF. CDF gives the probability of a random variable is less than or equal to a value x. So f of this is always written as a capital F of x is equal to p x less than or equal to x. So discrete sum of PMF, the continuous is integral of PDMF, probability dense function. So if it is like, if you want to sum all of this one, so for discrete, it will be CDF. For example, you can have like 1, 0.1, 0.2. If you sum this one, it will be CDF for discrete. But if you take the interval for this one, it will be continuous function. Then you have like expected value. You can see the expected value is the long run average value for random variable. For discrete, if expected of x is a summation of x times probability of x is equal to 1. So you can have x here and all of them. And for continuous is like interval of x times f of x dx. So example is like expected value of 1. If you count for a dice is 1, 2, 3, it could be 1, 2, 3, 4, 5, 6. So 6 divide all of this divide by 6, it will be 3.5. You can go through this on all. Variance and standard deviation. Variance is measure how much the value of x divert from the mean. So how much it divert, mostly it is used for statistics, but in here also, because if you want to find this one, so you can find through this formula. And also standard deviation, square root of the variance given spread in original units. And then you have example here. Let x be the output of a fair coin toss. X is equal to 0 for tails and x is equal to 1 for heads. So it's x is, if it is tails, it will be 0. If it is head, it will be 1. So it's 50-50. So now if your expected value is 0, 0 is for tails, because it is like, if it is 0, it means it's still 0 times the probability of this one, because we will go from this formula. So x is here. X is like the value 0, 1, 2, and this one is the probability of that one. Probability of this one is 0.5. You can see here. So it's 0 times 0.5 plus 1 times 0.5. It is 0.5. So expected value is 0.5 for this function for a fair coin. And for variance is like you will go summation of x minus expected value whole square. So you will have 0.05 times 2. It's in here, it should be, it's not 2, it's raised to the power 2. Yeah, it's raised to the power 2. Typo mistake. Then it is plus 1 minus 0.5 whole raised to the power 2, 0.5. So you can have 0.25 as a variance. The standard is if you take the root of this one, it will be 0.5. So this means for a fair coin, the average outcome is 0.5. So if you have a fair coin, so either it could be tail or head. So it is like 0.5, you can see. And the spread of the result is measured by a standard deviation of 0.5. So the spread is also 0.5. So you can go through these properties by yourself, properties of expectation and variance. So you can add, and if you add variance together, there is no any difference. So there you can add variance x plus variance of y. So you can do it separately. You can find variance of x, then variance of y, and you can add this one. Only if x and y are independent. So for example, variance of is x is 2 and this one. So you can just 2 plus 3 is equal to 5. So you can find a variance of x and y, then you can add it together. Or you can go from this one. You can find variance of x plus y. So you can do it whether this one or this. Scaling of variance, if you have a scale, if you have like a or any digit like 2, 3, 4, anything. So if you want to do it, so you can have to square this one. It will be square. For example, if variance of a is 4 and this a is 3, so instead of this one, so it will be 3 squared times variance of a. 3 squared times 4 is 36. Linearity of the expectation, so if there is any function, if there is any constant here, so you can put it, you can bring it out of that, so you can find expected variance of x, then you can multiply this constant. So it are independent and not so if you have like expected x is 3 and y is 5, then you have like 2x. I can take out these two outside for expected values, and then if you continue, so it will be ex is 3, so 2 times 3 is 6, and then is 3 is here and 5, 3 times 5. So it does not matter. So you can write it here as it is like here also like this. If I have just a second. So if I say 2 times expected of x plus 3 times e raised to the power y is equal to. So this is the same, whether if you take it this one out of this expected this equation, and then you can solve this together. Do you have any question for so far, guys? Are you sleeping?
No.
Any question?
No, sir, but we need to think more on these slides.
Yeah, you should go and work more on this one, okay?
Yes.
I will upload the slides and you can go through once again, and there are videos you can rewatch this one because it's not that easy also that you think. So probability distribution, we have normal distribution, bell curve, binary distribution, and Poisson distribution. So for normal distribution, you can see here, it's the normal distribution, binary distribution, and Poisson distribution. And you can see the definition here. Continuous data clustered around a mean, common in the nature and social. So there a mean is like 0 is a mean. So you can see the first standard deviation, second standard based on this here. So if you go from here to first standard deviation is like this chances that it's the most of the is 68.3%. The data should be here. If you go to standard deviation, it will be 95.4%, and for 3 standard is 99.7%. Yes, Zohra.
Sir, I'm just asking that could we have this kind of graphs through a small data set?
Yeah.
Is it possible?
Mm-hmm. For example, let's see, I will give you example here because I have already one of these graphs, so I can show you. Let me run this one. So you will just, so in here you can see import matplotlib.py plots as PLT. So you have a function, you have a library here in Python, it is matplotlib, where you can draw graphs. So this is your examples. If you go to examples, you can see here. So you can make these graphs. You can have statistic graphs, distributions. You can see here, like you can see here. These all graphs you can make it, and the good thing is like it's very easy. So you will just use the same import matplotlib as plt. So because to make it shortcut, so I just don't want to write every time this one. So I say as plt. So it's my shortcut. And also import, I have numpy, so import. Okay, so this is given. So import numpy as np, because we have another library, because it's also statistic. It provides an array object, fast and linear algebra, Fourier transform, and others. So there is another library in numpy. We can work it after the like after in statistics we can see this one. So there is this one. So you can, it's open source. You can see, you can make everything array. You can have these ones. Data science, for data science you can use these plots. So anyhow, if I have like this one, and this one is for my binomial, because I have n and p, so I'll just say x in values of n dot range 0 to 3. My x should be from 0 to 11, and also my function of y is binary, because it's just like a function. So you can see binom. Then if I just run this one, so you can see here. So you can see here, like from 0, the x is from 0 to 11. So you can see from 0 to 10, because it's in Python. And also this is the value of x value. So it is in binary, there is this function. So you can see here, this is a method. You can say a binary distribution. So it's you can just write here what binom is giving you distribution graph for binomial. Binomial, discrete, random variable as a string of random variable, discrete, and binomial. So you can see here, you can have like all the information are given for to you. So you can see the notes. So even this is also a code. So example is here. You can see this is the example. You can just take out the examples. If I just a second, if I
So
have
it's
this,
interesting working
just a
with this
second.
kind of graphs.
Yes, please.
I said working with this kind of graph is so interesting.
Yeah, we will see all the graphs. Like in the next data visualization, we will see there are plenty of graphs. So we will use this matplotlib, and there is another library, Seaborn. So you can find all of them from here. Seaborn. This is another library in statistic data visualization. You can see you can make lots of graphs with this one. So the codes are also given. So you'll just, if I, for example, just copy paste this one, so I can make it and I can visualize. So based on this one, you should understand what is. So if I load this one, oh, my data set is not here, so I still okay. So even if the data set is from, there is a data set planets, so it's just like load data set, its example is there already, so I can load this one on my system, so I can just change it according to my need, if I need those things. So you can do it here, we can see it later. So you can make any graph you want, it's not about this. So you can have like Poisson graph, you have like normal distribution curve. So if I say here, maybe I can find this one, normal distribution Python, normal Gaussian. See, you can, if I just copy paste this one, so it should give me, this should give me my, this, you see, this is normal distribution curve. So you can, I have with one, because C is Seaborn, so it's the library from Seaborn this plot. So it is just random. So it's a random you use within 1000 size. So it's 1000. If you change it to 100, so yeah, it will give you another curve. So it's like for 100. So it's just like you can do it. You can find this one from here or from there. There are plenty of libraries that you can do it. So matplotlib, you can see here. You can have these graphs. Every graphs you can find out here. You will just do it. Any question? Clear?
Teacher, which program, which website is useful for writing mathematical formula?
So there are plenty of these ones. Like there is NumPy is also in a library. So some libraries you can functions from library. You just go there, documentation. You can see you can read the documentation here. So you can see how home. So just a second. Yeah. Pandas. So this is Pandas is there for mathematics C is a fast and powerful, flexible, easy to open source for source data analysis and manipulation tools built on the top of Python programming language. So this is Pandas. So there are a lot of, so once you are starting, you will start with Python coding, then you can find plenty of this one. So Pandas is there. Even see Python for data analysis, data ring, Pandas, NumPy, and Jupyter. So this is a book for this one. This for graphs, you can use this one, Matplotlib, you can use Seaborn, because it's an advanced one, it's on top. So Seaborn is a Python data visualization based on Matplotlib. So it's based on this one, but it is now, it provides a high level interface of driving interactive and informative statistical graphs. Before people were using Matplotlib, now because it's on top of this one, now you can make very other good graphs. After this one, there is another one. What was the name? I forgot that one. Plotly. Plotly. There is another one. So this is another library. You can see library. Just give you another. So it's also here. If I go to examples, you can see examples. It's more beautiful than Seaboard and other ones. If I see. So it has more functionality. It will give you. See. So you can use based on your need. What do you need? So this is another library that you can use. Just you can import Plotly, SPLT or whatsoever. So you'll just import this one and you can get it. So this is all about here. Did I answer your question, guys?
Teacher, our group is preparing a mathematic book, teacher. These websites are useful for us.
Yeah, why not? Because you can show it into the graphs. You can make it anything that you want.
For writing integral,
Yeah.
and not just for graphs, teacher.
Yeah, like you can use like here pandas. Like you can see pandas. You can use math for integral. In Python. Which library you can? It's here. You can see here. Just a second, Zora. I will come to you. So Sci-Hub. You can see integration. So you can use from Sci-Hub, SciPython. So in here, so you can use all the integration here. See here, Prosite. You can use all of them. Samsung. You can say rope. It's all you can use here. The integration. So you'll just if I copy paste this much, so it will give you what is it? It's quad. It will give you quad. Let's see any function. Yeah, for writing this function, you can see you can write like this one from NumPy. So you can write these functions here. Now, if I copy this one and if I put it here, now if I run this one, special is not this special. Why what is this? Special is here. So if I because there is some special characters or something. So let me copy paste this one also here. If I run this one now I can see I. Its I is here. So if you see, this is the equation for I. They have written this much I. Under root of 2 divided by pi. This one is under root, this one. So this function is here. This one. You can see SI is this one, special character. So you can see SP. So you can write a lot of things. You can do all of them in Python with this library. You can go and documentation and see this one. Okay? Yes, Zohra? Guys, if you don't have any question, we are done with this. Now you can have your break. Then we will come and do other ones.
Sorry, sir. Atifa was talking about a group. Is it related to our course, which I'm not aware of that?
No, it was some. Not here recording. Okay. So I hope you are here. So now the second portion of our class, today's class is about statistics. So you can see learning outcomes, compute descriptive statistic, mean, median, mode, variance, standard deviations, compute inferential statistic, confidence interval, hypothesis testing, p-values, interpret distributions and statistical test results, evaluate data using measures of center, tendency, and vulnerability, and also perform hypothesis testing and draw conclusion from sample data, use statistical software or programming Python to analyze data sets, also communicate statistical findings clearly through reports and visualizations. Let's go. So why probability and statistic matters? Probability and statistic help us understand uncertainty. When the event is not certain, so you have to use probability and statistic. So it makes informed decisions and interpret data. They support science, guide choices in business and health, influence data daily life from predictions to technology. So as you all know, it's mathematically backbone of data analytics. If you are doing data analytics, so there should be some, you should know about basics of probability and statistics. And foundation for machine learning and AI, artificial intelligence. So in short, probability measures uncertainty and statistic turns data into insights. To understand the insights, to see the ingredients of your data, what is it and how it affects your variables. So you will use statistics. So now I have a question. What's the first word you think when you hear statistics? And also, can statistics ever be 100% accurate? But please keep in mind it should be short when you are giving your answers. Yes, please. Yes, Aisha, please go on.
Thank you, teacher, because give me this opportunity. And the first question, I think data. And second question, no, statics cannot be 100% because it is based on samples and there may be errors. Thank you, teacher.
Yes, thank you, Aisha, for your answers. Yes, Mariam?
Thank you, sir. For the first question, the first word that came to my mind by hearing statistics, it was visualization, it was graphs, charts, these things. And for the second question, I think which it depends to the how data collected. If data collected well and also it visualized well and accurately, so the statistics will be accurate. It depends on data.
So you mean that it could be 100% accurate?
Sometimes it can be, sometimes it cannot be.
Okay, so let's see. Okay. Anyone else? Yeah, Shukriya.
Statistics is a discipline that deals with data, facts, and figures with which meaningful information is inferred. And about the second question, it's not 100 accurate, but maybe it's 99%.
So no, you just give 1% less. Okay, that's good. Yeah. Any more ideas? Yes, Sakina.
Okay, in my opinion, as the answer for the first question, what's the first word you think of when you hear statistics? They might be the data, numbers, percentage, probability, chance, and other words. And as the answer for the second question, can statistics ever be 100% accurate? No, I think it cannot be 100% accurate because statistics is based on data, samples, probability, assumptions, and many other issues that in the middle of those data, there might be some problems that there might be some errors, mistakes, and absolutely that it cannot be 100% accurate.
Good. Yes, Mahjuba.
Okay, thank you, teacher, for giving this opportunity. When I heard for the first time about statistics, it means that statistics is a branch of mathematics. Most of the time, I deal with data collection and also data analysis and organizing the data. And also, it can be help us to take better decision making as well. But for the second questions, can a statistics ever be 100% accurate? I think for this question, statistics never can be 100% accurate because we will face some many problems and also some errors while working with the statistics, such as sampling error and also measurements of error. Sometimes when we are entering the data, there might be happen some misunderstanding and also some misspellings of the data, and also when we are doing some codings, it will be have some errors. So in this case, we can say that statistics cannot be ever be 100% accurate.
Okay, thank you. Mostly when you are playing with statistics, like you are praying that it should give you 60 or 70% result because it's also a big amount. But to get 100%, it means that wow, it's something unpredictable. So because when you start with statistics, when you start your Python coding or machine learning or something like this, so it will give you 50%, 60%. If you count it, it will just showing you like even if you show you can be 50%, you can gamble, you can say it's right or wrong. But sometimes the computer is also confused, it giving you 40% result. So it's just making you hard for you that you should go and see another approach or something. So let's see, can statistic ever be 100% accurate? Let's see how it works. So statistics is the branch of mathematics that deal with collecting, organizing, analyzing, interpreting, and presenting data. So these are the all works done by statistics. It provides methods to summarize large amount of information, identify patterns, make predictions, and support decision making under uncertainty. So if what is what? So we have two types of statistic. One is descriptive and the other is inferential. So first of all, descriptive statistic provides a way to summarize and describe the main feature of a data set. They are the first step in data analysis and help us quickly understand patterns, central values, and vulnerability. So if you are going to start with a statistic, first of all, you will just try to find out mean, median, or mode. So mean is sum of values divided by number of values. So if you have like summation of n xi divided by number of values that you have in your data set. This is the mean. Median is the middle value when the data is ordered, useful when data has outlier. So when there is any big amount of number outlier or something, which is like someone earning like 100,000 Afghani. So it's an outlier because people average is like 25 to 40 per thousand Afghani. But if someone earns more, so it is. So sometimes for such scenarios, median is better than doing mean because mean will take all the numbers. So it will include the 100,000 Afghani also, but for median it will give you the median value, which is mostly inside when you order this one. So if n is odd, median is middle value. If n is even, median is average of two median values. So you will add the two median values and divide by 2, and then it will give you median of them. So mode is the most frequent value, helpful in categorical and repeated data. Data can be unimode, bimode. If it is bimode, it's two modes, and multimodal. Then you have variance, variance of squared deviation from the mean. So how much it shows the spread, that how much it's spread from your mean, how much it is the far or near to your mean value. So you have like if it's population, there is capital N, but for sample variance it's n minus 1. So standard deviation is square root of variance. So you'll take square root of your variance. It will give you spread in the same units as the data. So it will give you the standard deviation. So for example, you have like calculating mean, median, and mode variance of this one. So you have 2, 2, 6, 8, 10. So you can find, like, you can do it in mathematical. I don't think I should go it with this one. But what matters for me is that I will go and we will do it into Python. So for the Python process, like I have all the codes here. You can see here, you can do it later, but I will just go here, down here. So for finding, first of all, if you have like a sample space, like you can have a data, for example, it was data is a list of numbers, like you have 2, 2, 5, 6, 11, something like this. If you have this much amount number, then if you try to find the mean of this one. So I will just run this one. Then I can just find, okay, I should import a library, which is like I will import NumPy, because if I say NumPy for statistics, you can see statistics, I can find many operations of statistics here. So I can find percentile, non-percentile, everything like quartile, non-quartile, median, average, mean, standard deviation, variance, everything I can find through this library. So I will just write import NumPy as NP whatsoever for my shortcut. I will just try to find out these values for descriptive. So I can find histogram, these all things with this NumPy. So you can see here, and if I go, for example, mean, so I can go and I can read all the documentation. What can I do with mean? So you can see weighted average. The arithmetic mean is the sum of elements along the axis divided by the number of elements. So it's just a very good definition. I will just say import NumPy as NP, and then I will run this one. If I run, so I'll just now for some length, n is equal to length of my data. So I need this one also, because I need a length for this one, or even without length also, just I'll say that mean, I will say that print np dot mean, np mean of what? Data. Then I will just print this one. So the mean is just like this much. You can see 10.125. So it's just the mean. If I find out a median of this one, I will say print value, and I will say NP, because you can change here, but mostly people are using NP. So if I just say anything, you can put, I can put here Zakir, so you can just write here Zakir. But the best use is that, okay, I should run this one first of all. Now I can run this one, so it is giving. You can as means whatsoever. You will give a dummy name for this one. It could be NP, it could be something DP or something whatsoever. So mostly people are using NP because it's just like a dummy name that everyone knows. When you write here NP, it means that it's a NumPy. Without any looking towards the library, it will just understand that it's a NumPy. NP dot like median. So you can see, okay, of what? Median of my data. So I will give my data. So it's like 5.5. It should be even. 2, 6, 6, 8, and yeah, so it's an even number. So it is like giving you the median of two number. It will add and divide by 2. So it is 5.5. And if you got like variance, if you say var, then you can see here data. I run, if I print, because it's just giving me, but if I print this one, it will give me the output also. So it's the variance is this one. If I say print std, std is like np, so np dot std, it should be std of data. It will giving me the standard deviation of this one. For I think for mode there is no such one. Let me see if I can, if there is any other library for mode. np dot mode of data, maybe. Oh, so there is no attribute mode. if you want to see more in statistic using Python, you can use statistics.mode. So there is another library you can use for if you want to find. So you can use these statistical. So if I say now I have to import this one for this one. So I don't have to in NumPy. So I will say import statistics. So if I say now instead of this one, I will write here statistics. Or you can see if you say as for example s whatsoever, so it will then you don't need to write here, you just write here s. But if you just directly import without anything, so you have to write all the things here, statistics all. So you have to make it shortcut, we use s something. But if you don't want, you have to do like this, and it's 2. So how there is 2, so there is 2, so is 2 times frequency is 2. So this is like this. But if you just say as E or S, so now it's shortcut for you. You just need to write S, so it will give you. But if you don't write any shortcut something name, so you have to write all the name of this. So that's why people are using as a shortcut for themselves NumPy as NP. So it provides an array. So it's just like shortcut for this. So do you have any question so far?
Teacher.
Okay, that's
No,
good.
sir.
Okay, that's perfect. So now we have here the simplest measure of the spread in a data set. So we have range. It tells you the difference between the large number and the smallest number. So you can say range is equal to max of this one. So if you have like an amount, so you can have the maximum of this one and in the minimum. So it will give you the 15. Then you have interquartile. You have interquartile for this one. So you can see interquartile is the range of the middle value, 50% of the data. It ignores extreme values, outliers, and focus on the split of the zone. Interquartile is quartile third quartile minus first quartile. You can say 75 percentile minus 25 percentile. So if you have like this one, it should be orders. Then if you find first quartile and second, so you can have this one in real world. Any questions so far?
No, sir, no question.
Okay, let's try to do it in Python if it is possible. For this one, so you will just have the same as the data. Let me copy paste the data, or let me just copy paste this data. If I say data 2 is equal to this list of number. Oh, I forgot, I just copied those. Why it's not working? Copy. Oh, it's not working. Yeah. Okay, let me write manually. Or you can write anything, so it's up to you. It's not that it should be the same. So if I say this is my data, so I will just say the range. For the range is just like you will just use the function max and mean value. So I will say range, data range is equal to max of the data, maximum number of data 2 minus minimum number of data 2. So if I just now write print, or I can write here down also, I can write print my data range. Why is typing is not working today? The range is 43. If you have 45 is the biggest number, the lowest number is 2. 45 minus 2 is 43. So you can just do the same like this. For this one, if you want to do interquartile, so you will just use NP again. So we have already NP here. So I will say that first quartile is equal to NP dot percentile. If you have remembered here, it was there 1 percentile was there. percentile. So find out percentile is here. So you can see 25%, you can see whatsoever. So you can here write np dot what percentile. So if I say percentile, so it is giving me data, so I don't need this is very good nowadays that it's showing you everything, but I will say my data 2 and it's 25, it's first 25 percentile, and if I say 75 percentile, then I will say Q3 is equal to the same np dot percentile and data data 2, and what is 75 I will write. And if I say interquartile, I will say QR is equal to Q3 minus Q1. If I print this one, so I will just write print IQR. So you can find here. If you need 50%, you can just use median, or you can cite instead of 25, you can write 50. So this is how you can do it in Python using library of NumPy library. Any questions so far, guys? Question?
No questions, sure.
Okay. Let's see a little. Do you need to show the video for this descriptive? Because it's easy. I don't think that you need this one. Should I show you for descriptive?
If you want to.
Hello?
Yes.
Do you need for descriptive analytics the video to be shown or no?
It was easy, sir.
No,
It's
sir.
easy. I think it's easy. No need to go for this. It's waste of time. We will see for the rest. We will see the for inferential statistic how it is. For descriptive, it's just like math of class 6 and 5. Okay, we will see. Yes, Anahita. Yes, please.
Sir, because I had some problem with my laptop and I couldn't hear a few minutes, if you could just share the link of the video, I will see it by myself. Thank you so much.
You are welcome. I will share you everything here for you in the Google Drive. Okay. Even I have the recording for the class as well today, so I can
Thank
share
you
you the
so much.
recording. Okay. So inferential statistic is the branch of statistic that allows us to make predictions, decisions, and generalization about population based on a data collected from a sample. So this is very important. Now people are mostly they go for this portion. Since it's usually impossible to measure an entire population, inferential methods let us estimate population parameters and test hypotheses using sample data. Because you cannot see all the trees in Afghanistan or in Kabul, so you can see that, okay, the population of trees in Afghanistan or in Kabul. So you cannot do it all. You cannot measure all of them with the height of this one or whatsoever. So for that reason, you will use some sample data. So you'll just see some of the height of some of the trees. Then based on this one, you'll just try to do your hypothesis or your test everything. So we have estimation, point estimates like sample mean, and interval estimates, confidence interval, which should be between some intervals. Hypothesis testing, testing claims about a population like t-test, chi-square test, something like this. And at the end, there is ANOVA, analysis of variance. So it's comparing means of multiple groups. And so if you have like 2 or 3 means, for example, of student school A, school B, school C, so you'll see in ANOVA to see analysis of the variance. So estimation in statistic is estimation helps us sample data to estimate unknown population parameters like population mean, proportion, or variance. So we have two types. One is point estimates, a single value used to estimate a population parameter. For example, if you have a point, like we survey 100% of from the exam and the example mean is 75. So it could be 50. It's only a point. It's a dot. It's if you have a population, so you pick up one of them. So it could be one of point estimates. So this sample mean is a point estimate of the true population mean score. But you have interval estimates, which is confidence intervals. So an interval range from the value is likely to contain the true. So could be wrong because you have just chosen one of them. But if you have interval, confidence interval, so it could be you can with a certain level of confidence that it could be like 95% you are confident, you can be 90%, or you can be 99% confident that my true population parameter is within this interval estimation. So why it matters? Unlike point estimates, which gives just one value, confidence interval shows how precise and reliable our estimate is. For example, you say for the survey, for this survey, for the survey of height of the trees in Afghanistan, we compute 95%, or I am 95% sure, confident that the height is between 72 to 78. So it's an interval. So interpretation we say like this. So this is the way. It's also very important to say we are 95% confident that the true population mean score lies between 72 to and 78. So when you are telling about interval estimations, please keep in mind that you will show that how much confidence you are. 95%, 90%. It's up to you. It could be like 99% confident, or so on so forth. So interpretation is like this. So I have a code here, so you can see here, like let's run this code and see how it works. I should just copy paste, maybe it should work for me. Let's hope for the best. Okay. Oh no, it's I think I should find out first of all Notepad. I will get Notepad. Now it should work. So I will just paste in Notepad and I will just paste. Now it will give you here, it will work. Yes. So if you are directly doing it from PowerPoint, but it's not working, so you just copy it into Notepad. From Notepad, you can copy it into this one. So you have a data. This is your data. Like this is some values, or maybe for a height, maybe for any weight or something. So you have your point estimate is that again you will use NumPy, library of NumPy. So you say mp.mean of the data, so it will just give a point. So that mean is your true mean population for that one, and it's point estimate. If you find out the mean is the same average or mean that we are using, so it is giving you point estimates. But if you want to do it for confidence interval, so you say that confidence interval of 95 or 99, or it's up to you. Then you need the length of your data, so how much is it, and then you will use like standard error sim. This is in statistics, so this function comes from here, standard error in statistics. You can see standard error of mean in Python. You can use sim. You can see here, this is the shortcut sim. This comes from this library. You can see sim, so you can have sim. What it does, it calculate the standard error of mean, standard error of measurement of the values in the input error. So we need the same error, so we need this one. So for this one, so we will count, you will find from this library sci.stats, and this is the word sim. So they have done the same. So in here you can see import this library as stats, so it's the name shortcut, so stats.sem, so sim. So you can say calculate compute standard error of the mean. So standard error is done with this one. And for just a second, Mariam, confidence interval, so it's the same. Again, you'll just do t confidence. So you can see confidence is also should be here somewhere here, maybe in here. If I go here, let me search. It should be somewhere. Search should be. It's not search bar. Wow. Here it's here. I say confidence. Confidence interval. So you can see confidence interval is here. You can find out from here. And what is it? Yeah, and so it's like the same. States.interval. So you can say 90 confidence is from here. It's giving you from here parameter, and this is the formula that you've put inside this all. Then you can see print this one, and if I print the value, I can see for this one, my point estimate is like 75.8. We are 95% confidence that this is between 73.89 to 77.70. Yes, now you can ask me, Mariam.
It has already solved, sir.
Yeah, it has already solved.
Yeah, no, I said that my question was solved.
Okay, yeah, so it's just like you can see, you can put here, this is the function that you can use it to estimate understand confidence interval. So in here, if you see, so this is correctly distribution, so it's confidence interval of population means. So we have used this psi stack. If you say, if I go any of these one, this function, so this is C is like continuous. This is the function that they have done. So it's even there is a formula for you, everything is written here. And how it works, it's already there. Everything is here. And a second, this is the graph. Even you can make a graph for this one to understand it better. Yeah. So this is like NumPy, statistics, matplotlib, and also other ones. This is how you can do it from interpretation of point estimates and interval estimates. Then we have hypothesis testing. This is null value. Null. We have two of these one: null hypothesis and alternative null. A statement that there is no effect or no difference. It's null hypothesis. So it's an assumption. I start with the very good, so without any difference. So I'll say that is equal to mean is equal to this, or is greater or less than equal to this one. So this is my null hypothesis. But alternative is a statement that is an effect or difference. This is what we want to test. So our assumption is here, we start from here, but we are testing whether it's alternate is fine or not. For example, in here it's school introduced a new teaching method. We want to test if it improves student test scores compared to the traditional method. So our null hypothesis is the new method does not improve performance. It means that mean square is the same as the traditional. But for our alternative, it is that I'll say that the new method does improve performance. So mean square is higher compared to the other one. If I have example for in Python, so we can say interpretation. Let's see if I have. Yeah, so this is the code. I think this is all the code. So we can go one by one and we can see how it works. So a confident interval gives you a range of values where we believe the true population parameter lies based on the sample. So we just did this one. So a 95% confident interval means if we repeated the experiment many times, about 95% of the calculated intervals would contain the mean. So if you do it 95%, so you can be sure that it would be mean is inside that one. So after testing, so it's just like the result for this one, for this example. So after testing 50 students, the mean score of the new is 78 and the 95% is like 74 to 82. So we are 95% confident that the true mean square of all students taught with the new method lies with this one. So this is the confidence interval. Then we have like p-values and significant level. The p-value is like the probability of observing results as extreme or more extreme with those found if the null hypothesis were true. Then we have significant level threshold. We set commonly like 0.05. So we say that if it is our p-value is less than this significance level, we reject our null hypothesis. So it's up to you. It could be 0.1, 0.5. So mostly it's commonly it's 0.05. So you compare this one. So and we check it. So in here for this example for student one, our p-value is 0.02, which is like 0.05 is greater than 0.02, which means that we reject the null hypothesis. What was our null hypothesis? Our null hypothesis was the new method does not improve performance, which means we reject this one. It means that which means that the new teaching method significantly improves performance. So there is some, if you change your method, new method is more helpful based on our previous traditional method that you are having. So we can see here, I should run this one maybe. Let me go for Notepad because it will not give without this one. Somewhere, if you have a question, please ask me, because there could be some portions that you might not understand. Oh. So now let's go one by one. So this is our some data from our traditional school. Like we have taken sample from traditional method, and new method is this one sample. So we have some like survey or whatsoever. So we want to see this one how it affects. So we have a mean of the traditional value. First of all, we have the mean for this one. So it's the same p dot mean because we have used NumPy library from here module. So then for mean of the new one, so we have np.mean, so new method. So we just find out the mean for these two, our two data set. Then we print this one, so we use print function. Now we are using hypothesis test. What is our hypothesis? T-test is like this t-test and p-value is equal to stats dot t-test. What does it? It's a built-in function. It's built-in function. So it calculates the t-test for the means of two independent sample of scores, a tradition and a new model. This is a test for a null hypothesis that two independent samples have identical average expected values. This test assumes that the population have identical variance by default. You can see here, this is the definition. So it's check the new method, so this method and traditional. Its alternative is greater. What is greater? New method is. First, our null hypothesis is that there is no any changes. But I said that new method is more effective or is better than the traditional. Better. So this is greater. Alternative, our alternative hypothesis is here, alternative. So I print the t-test and p-value for this one. It's giving you the p-value and t-test. Now I will see the difference of this one. So I see the mean difference, mean of value of this one from here minus traditional, and then I set my standard error of difference. So if I see standard error of difference, there is a formula behind this one. Formula, not interested. So this is your formula for this one. So you will just write this formula. It is here n square root of np.var variance of what? Traditional by degree of freedom 1. So you can see here this one. This is variance for this. And then you have like divide by length of this one. Length is here, n1. Can you see n1? So this is s1. S1 is variance. So this is the variance, square of variance, and divide by n1, which is here, length of that one, the length of, and the same plus, there is a plus for this one, and the second one, you can see variance of the new method divided by the length of this one. So you can see here s square is here, s square is a variance. So you can see here standard error of the difference quantifies vulnerability between two sample means and population with the defining this is the formula. So you have just wrote this formula here. Standard error of difference. Now for degree of variance, so you have used Welch approximations. So you can say degree variance formula. So there is another formula. Okay, I can see this one. So you can see formula. So this could be formula for this. So this is the formula for this. Based on this formula of mathematics formula, so they have just here, what is this? This degree of freedom is the formula that this formula is just written here. This formula just written as it is here. Then you can see the 95%. If you run this one code, now you can see here So t-test is 8.89 and p1 is this one. So it's the difference is this much. So we are confident that it's, and we reject our null hypothesis because it's like 0.02 it was something like that. Do you have any question, guys?
Sir, why it's showing in output np.plot?
This one?
Yes.
Because we have not printed that one. We have to print that one. If I say print do and so this is your print function because you have not printed the function. So this is not printed. So that's why that is giving you error. And also if I say print ci high, now it's giving you the amount here. This is 8 and this is your upper interval and this is your lower. Okay. Did you understand?
Yes.
Yes.
Yes. Do you have any question?
Sir, isn't that enough for today because we need more practice?
How is it? Is it difficult?
Yes, this part was
Just this,
difficult.
it's enough. Only this portion enough. And I will show you a video because you should understand what is. Okay, I will just go with this one and this enough. Okay. Zora?
Still, it's too much,
Are you
sir.
sleeping, guys? Or are you here listening? So I will just do ANOVA and we will be done with this. ANOVA is video
Please
and I will
break,
show you a video of this one, just this one. So
please
this
break
is
in
only
this
ANOVA
part,
is a
please.
statistical. This one you are done?
It is so difficult, and the last part was difficult.
Okay, so let's. Okay, then you should read it yourself. Like I can go and show you the which one was difficult. Let's see how where is it. So you can see these videos. Okay, range, variance. This one is no. I need standard deviation. Okay. The quartile, you know these ones. I think it should be. Go through this video. It's very useful video. I'll just go where where is it? Okay, it's here. Expressions. Okay. Just we will watch this one and then you can see the rest by 12 minutes. You can see because there is too much information and it's very helpful. This video was very helpful.
What inferential statistics is, and then I'll explain the 6 key components to you. So what is inferential statistics? Inferential statistics allows us to make a conclusion or inference about a population based on data from a sample. What is the population and what is the sample? The population is the whole group we're interested in. If you want to study the average height of all adults in the United States, then a population would be all adults in the United States. The sample is a smaller group we actually study, chosen from the population. For example, 150 adults were selected from the United States. And now we want to use the sample to make a statement about the population. And here are the 6 steps how to do that. Number 1, hypothesis. First, we need a statement, a hypothesis that we want to test. For example, you want to know whether a drug will have a positive effect on blood pressure in people with high blood pressure. But what's next? In our hypothesis, we stated that we would like to study people with high blood pressure. So our population is all people with high blood pressure in, for example, the US. Obviously, we cannot collect data from the whole population. So we take a sample from the population. Now we use this sample to make a statement about the population. But how do we do that? For this we need a hypothesis test. Hypothesis testing is a method for testing a claim about a parameter in a population using data measured in a sample. Great, that's exactly what we need. There are many different hypothesis tests. And at the end of this video, I will give you a guide on how to find the right test. And of course, you can find videos about many more hypothesis tests on our channel. But how does a hypothesis test work? When we conduct a hypothesis test, we start with a research hypothesis, also called alternative hypothesis. This is the hypothesis we are trying to find evidence for. In our case, the research hypothesis is the drug has an effect on blood pressure. But we cannot test this hypothesis directly with a classical hypothesis test. So we test the opposite hypothesis, that the drug has no effect on blood pressure. But what does that mean? First, we assume that the drug has no effect in the population. We therefore assume that in general, people who take the drug and people who don't take the drug have the same blood pressure on average. If we now take a random sample and it turns out that the drug has a large effect in the sample, then we can ask how likely it is to draw such a sample or one that deviates even more if the drug actually has no effect. So in reality, on average, there is no difference in the population. If this probability is very low, we can ask ourselves, maybe the drug has an effect in the population. And we may have enough evidence to reject the null hypothesis that the drug has no effect. And it is this probability that is called the p-value. Let's summarize this in 3 simple steps. Number 1, the null hypothesis states that there is no difference in the population. Number 2, the hypothesis test calculates how much the sample deviates from the null hypothesis. Number 3, the p-value indicates the probability of getting a sample that deviates as much as our sample or one that even deviates more than our sample, assuming the null hypothesis is true. But at what point is the p-value small enough for us to reject the null hypothesis? This brings us to the next point, statistical significance. If the p-value is less than a predetermined threshold, the result is considered statistically significant. This means that the result is unlikely to have occurred by chance alone, and that we have enough evidence to reject the null hypothesis. This threshold is often 0.05. Therefore, a small p-value suggests that the observed data, our sample, is inconsistent with the null hypothesis. This leads us to reject the null hypothesis in favor of the alternative hypothesis. A large p-value suggests that the observed data is consistent with the null hypothesis, and we will not reject it. But note, there is always a risk of making an error. A small p-value does not prove that the alternative hypothesis is true. It is only saying that it is unlikely to get such a result, or a more extreme, when the null hypothesis is true. And again, if the null hypothesis is true, there is no difference in the population. And the other way around, a large p-value does not prove that the null hypothesis is true. It is only saying that it is likely to get such a result or a more extreme when the null hypothesis is true. So there are 2 types of errors which are called type 1 and type 2 error. Let's start with the type 1 error. In hypothesis testing, a type 1 error occurs when a true null hypothesis is rejected. So in reality, the null hypothesis is true, but we make the decision to reject the null hypothesis. In our example, it means that the drug actually had no effect. So in reality, there is no difference in blood pressure whether the drug is taken or not. The blood pressure remains the same in both cases. But our sample happened to be so far off the true value that we mistakenly thought the drug was working. And a type 2 error occurs when a false null hypothesis is not rejected. So in reality, the null hypothesis is false, but we make the decision not to reject the null hypothesis. In our example, this means the drug actually did work. There is a difference between those who have taken the drug and those who have not, but it was just a coincidence that the sample taken did not show much difference. And we mistakenly thought the drug was not working. And now I'll show you how DataTab helps you to find a suitable hypothesis test and of course calculates it and interprets the results for you. Let's go to datatab.net and copy your own data in here. We will just use this example dataset. After copying your data into the table, the variables appear down here. DataTab automatically tries to determine the correct level of measurement, but you can also change it up here. Now we just click on Hypothesis Testing and select the variables we want to use for the calculation of the hypothesis test. DataTab will then suggest a suitable test. For example, in this case, a chi-square test, or in that case, an analysis of variance. Then you will see the hypotheses and the results. If you're not sure how to interpret the results, click on Summary in Words. Further, you can check the assumptions and decide whether you want to calculate a parametric or a non-parametric test. You can find out the difference between parametric and non-parametric tests in my next video. Thanks for watching, and I hope you enjoyed the video.
So you can go to your this and you can find out through data what? Data. So this one you can just see, so it works perfectly. So you can see or check it, everything. Like if you everything, it will give you that what should you use, histogram, like age, everything. And then you can find from here what you need, first quartile, second quartile. So this is one of the websites. You can see, go to statistics, and then you can choose as it was here, like here. So it will give you test for independent sample. So this is a good test to do if you are checking for a gender and age. For salary and this one, so you can use again, it will be t-test. For company, you can have this one, ANOVA, because they are different. So this is a very good way. So you can see regression, correlation. You can calculate the correlation, everything based on this. So this is a very good website. You can do it. You can go to this one and see if you have any data. If you don't know what test, which test you want to use it, you can try to, it will help you find out the best test for your data set. So I hope it was helpful for you. Do you have any question, guys? Let me stop my screen. Now, do you have a question?
No question, sir. About assignment, teacher, we should send your email for you.
Just a second. You will send me through email. Let me stop recording here also. So I look forward to have your screenshot. Okay, I also look forward to have it because it's all about. Okay, just a second. I will show you the recording also. Let me first of all put the. So you have two quiz today. Okay, quiz number 3 and 4. So you will have quiz. Let me open the quiz number 2, data analytics. Please. Guys, please write in English in the main group, but you can write to me personally in Farsi. Okay. Please, can you check? Can you go through quiz number 4 and check whether it's working or no? I shared the link into the
Yes,
group.
it is working.
It's working.
Yes.
So let me share my screen again for you. Let me see what's going on. There are plenty of things going at a time. So Zahra, you asked for
Teacher, you can share the recorder of our
yeah, I'm
lessons.
saying okay. So there is OBS Studio. You can go there and you can see OBS Studio. You can go and just download this one. So installer, you can download the installer and it works perfectly. It's free, open source. You can do recording, you can do live streaming, you can do like everything you can do. So if I just, you can see here, like this is my recording, so I can do here. So I can choose from here. I can do application, audio capture, audio browsing, display capture, game capture. You can even do gaming here, images, media source, everything. So you can video capture, everything you can do it here based on your need. So for me, I'm using, like, for example, display capture. So I'm recording in here. So it's, I open now my videos. So you can see here part 2. So it's just like here if I open.
Thank you, teacher, because give me
So
this
it's just here.
opportunity.
So you can see here. So it's, and it's, you can record, like this is 52 minutes and the other one is like 1 hour something. So the other one is, this one is 1 hour 43 minutes. So you can do based on this one. You can use OBS Studio. Clear?
Yes, sir. Thank you so much. OBS, yeah.
OBS.
Yeah, thank you so much.
Let me put it in the group so that you should be. So
Can be used in
I put it in the group, so you can just go and download from there. I had so please go through this one, quiz number 3 and 4. Just do it inside from the links, and just don't give ask request from me, because it works with the links. So you don't need to ask for any request or something. Okay.
Sir, but how about the assignment? Just do the assignment 3.
Just do assignment 3 and share it to my, what was it? My Google Drive.
Okay, sir.